All right, so we are recording live. So this is where you don't scream out obscenities in the classroom, right, guys? Empress is like, yes, I was all planning to, but now you said no. So welcome to Programming 210. So normally I have a microphone. I got to get more batteries because, of course, it died. So it's probably going to be a little harder to hear today. But a couple of things I want to go over in this class. What do we expect? What are we going to look at? What's our schedule? All those kinds of things. So if you would join me in going to Blackboard and you would click on Assignments. And at the very top, you'll see that we have a syllabus listed. And it will take about 2.5 seconds, maybe a little more. And you'll get this great document out here, wherever it decides to open in which window. And so a couple of things. Now, it looks weird in this formatting. So if I click Enable Editing, it's a little easier to read. And it doesn't drop my formatting. So a couple of things to note in there. You guys on campus, or if you're online and you're on campus and you want to find it, my office is right around the corner. Most of you guys already know that. I also hang out in this lab, or try to a lot, because we've got a lot of work in terms of maintenance and upgrading and all kinds of fun things. So if you're on campus, you try to find me. Look at those two. I have office hours when I am here on campus. As we all know, we have meetings that sometimes affect those. I try to put a note up if I'm not here. But I'm also here a significant amount of time not listed on them. Those office hours are kind of a weird contractual thing. We have to list a set number of office hours. So the best thing to do is send me an email. I generally respond to email unless I'm sleeping or in class pretty quickly. And so send me an email and say, hey, can I get together? Can we work on something, whatever. I do a lot of things with like Google Voice and Google and Skype, so we can a lot of times find a way to do that. My office number, those of you that have been around our phones for a while on our campus, you know that they're crap. That number will, if I don't pick it up in my office, routes to the secretary, and then I'll get a message or a note at some point. If you really need to leave me a voicemail, I give you my Google Voice number, that 957-1320. The other thing you can do with that is most of you probably send text. If you want to, you can send a text to that number. And I can actually send and receive text to that number. So my Skype address is also listed there. Well, obviously those of you who are here know, and everybody, this is kind of a first for me, everybody's actually here the first day. Usually there's somebody that doesn't show up. So kind of excited. One thing to note, all of our weeks and our assignments, to kind of keep everything in sync, we always end Sunday and at 10 p.m. And the reason for that is, that way I don't have to stay up late, because I'm getting old, I can't hardly stay up for, games go into overtime, I can't even stay up for that anymore. So we end them. You require textbook. This should be super cheap. I don't know, did anybody buy it from our bookstore? What did it run you at the bookstore, do you remember? 25, 30 bucks, hopefully. Hopefully it's not very expensive. It's an older textbook. If you don't have it, you need to get this book. You will need it in the next couple of weeks. We don't need it the first couple of weeks, but don't forget to order it and get it here. You can find this in addition to our bookstore. You can find that on Amazon, half.com, any of these websites. Used is fine, cheap is fine. It's an older edition of a textbook we're using. So. And the doctor is fine. All right, so a couple of other things. You will need a word processor. I don't care which one. Most of you have already had some form of a word processor. You don't need to buy Microsoft Office for this class. So what are we going to do? We're really looking at the idea of how do we begin to think programmatically? How do we break problems apart? How do we create algorithms? How do I create a solution for a problem? And it doesn't matter which one of the 600 plus programming languages we use, we're looking for that, how do I find a solution or a method to get there, is really what we're looking for. So, algorithm development, programming knowledge. So we're kind of giving you that little base before we set you loose in the world. So, you're going to have a couple of different kinds of assignments. You're going to have written assignments, you're going to have some coding assignments, You're going to have coding assignments in a specific programming language. So it is offered in this hybrid format. So everybody gets the same assignments. We'll all try to work together. So it's kind of an interesting experiment. So we try to record everything. If technology goes bad, then we'll try to find time to do something. So even if you're in class, these are a great way to then reinforce, hey, I forgot how we do something. Let me go back and look and see what's going on there. So that's generally available at some point. So class attendance and participation, because it's a hybrid class, and I want to be as flexible. If you have something that comes up, so maybe you're a vocalist in a choir, you're not going to be here on a certain day. Everything's available online. So while I do kind of check attendance just to see who's really here, because if suddenly it's only Empress and I'm looking around and everybody's gone, that's kind of a weird feeling in here. But if something comes up and you need to miss class, if you're here on the physical class, we can work around it. So that's one of the advantages to this. Or if you're on some kind of activity here at campus, or you're sick, whatever. So weekly we're going to have an assignments, and I'll show you that breakdown because it's a little different in this class. There's exams, including there is a final. So a couple notes about the final. If you are in this class physically today, you have to be there physically for the final during finals week. So it's one of those policies we get handed out to us. So late assignments, well, don't. Because the way this class is structured, when we all work on a similar type of programming project, I can't take late assignments. If you're late, you're a 0. And the reason for that is once we start talking about a solution to a problem, it would be really unfair to allow, well, let's go back and you can redo that. So if, however, you're sick, broken, something happens, car wreck, accident, hang gliding accident, whatever, we can work out ahead of time or try to figure out an alternative assignment to things. But once that assignment time has passed, it makes it really hard to do something. 90, 80, 70, 60, roughly 650 points in the class. Depending on how we progress, that could change. We could add or take away an assignment, perhaps. Depends on how we're working together as a class. So there is a policy and incomplete policy. So if you get sick, broken, car wreck, accident, hang gliding, paragliding, whatever happens, you're already partway through the class, you're in the hospital for 6 to 8 weeks, you want an incomplete for that, I can grant one for you. It is not a magic I passed the class though, so I will always throw that out there. A couple of things have to happen. You have to have more than 50% of the course done before you're even eligible for an incomplete. You cannot be a senior having applied for graduation to get an incomplete. And the rate of people taking an incomplete and actually passing it is very, very low. So sometimes we get the idea, and I always throw this out there, that it's not a great cure for I forgot to do my homework or something in a course. So it has a place. The problem is you're sick half of a semester, something happens, then you have 1 semester to complete those. Well, you've already got another full load of courses. How do you find the time to complete those? And so I am at about a 20% rate of people who have ever applied for incompletes actually finishing them, unfortunately. And that seems to be fairly typical across the campus. So, in other words, work with me and we'll find a way, a solution, a better one for that. So, blah, 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 blah. If you don't get it done by the end of the semester or whatever term we specify, it automatically becomes an F. Talk to us. Don't just miss 6, 8 weeks of school and then go, hey, by the way, I was sick. We're not really that scared. Integrity policy. So this class is a little different and a challenge for me when we talk about academic integrity, because I want us to work together and solve problems. And I'm going to tell you, hey, there's all these code sites. You can go out and look at samples of code, and you can, in some cases, use pieces of code. And yet, I want you to do your own work. You have to find solutions. Can I incorporate other people's work in my solutions? Sometimes the answer is yes. But if I am simply copying and pasting from another student, that goes over the line of you didn't really solve the problem. And so what I generally do in here, if I really suspect that you didn't solve a problem on your own, I create one very similar, and I just ask you to come to my office or on a web Skype session, and I have you work me through how you would solve that problem. And it's pretty clear then if you didn't solve the problem on your own. So I encourage you to work together, but there's a fine line, and so sometimes that gets a little fuzzy for people. All right, so in other words, don't cheat. Title IX compliance, we want to be equally fair to everybody, no matter race, religion, color, creed, whatever, how we separate. And I think we do a pretty good job here. My theory is this really says I can pick on every one of you guys equally, right? And hiding over the corner, Rachel, doesn't help because I can still see where you are, even though you hide behind the monitor. So we try to make sure, if you think that there is an issue, whether it's this class, whether it's on campus, the world isn't perfect, but we can try to make it a better world. There is an address to our Director of Human Resources. And guys, we have had issues on campus with behavior of students and other things. Hopefully it's never an issue in this class. If you think you're being untreated fairly, speak out about it. And hopefully we can treat everybody freely. All right, so tentative course schedule. So if you look at this, this is kind of our work weeks and how we're going to do it. So notice I put the final down again. And then you'll notice here we're looking at something called an ebook. And there's a quiz and an assignment. So this is actually a book we're going to show you that you don't even have to buy. Because it hasn't changed, and I found a copy available of a first edition. Instead of charging $100 for a book called Programming Logic and Design, we've got a copy that we're going to use that's in PDF form. And so this kind of gives a breakdown of where we're at in the entire class. They're also listed by week. So I'm going to close out of the syllabus. Really quickly, if we make a change on the syllabus, something that impacts it, I will post it, and generally we will get some kind of a buy-in for that. So I'm going to take a look at week 1, and I have tried to put the week ending date on every one of the folders to make it a little easier to keep track of, because I know once we get in here it's a little hard to remember when is week 4, what is week 5, and that way we can all keep track, because I lose track just as easily as you guys do. So again, my specific note saying there's quizzes, there's blah, blah, blah. Your first assignment is actually here. Your first quiz is there. But that first link is one you should download onto your computer, store it somewhere. You can always go back, but it's stored in week 1. And that is actually the textbook that we're going to use for the very first couple weeks. So if you click on it, and I encourage you to hit open in a second window, it's a little easier to see. So this is a PDF copy of a textbook called Just Enough Programming Logic and Design. So notice we didn't say way too darn much, we said just enough. We don't want to scare you. So this book is an older edition. Zeros are still zeros, ones are still ones. And so this first week, if you go back to our schedule, we're looking at this idea here, an overview of computers and logic. So it's hard to sit down and program if we don't know what we're doing in terms of a basis. So, is anybody in here a Huskers football fan? Come on, be brave. There's got to be at least a Husker in here fan. Spencer, you're not really committed to that. You're like, yeah, sort of.
I watch it when I feel like I'm not.
Okay. So, did the Huskers do really well with complicated plays this year? And what were they missing in a lot of cases? Could they tackle? Did they know how to wrap up somebody in a tackle even? We're missing those basics, those fundamentals. So similar type of of situation here. We need those basics and we need those fundamentals. So we're going to go through these 7 chapters in this book. And we're going to look at them. So your book is free for a while. So if you haven't got the Python book yet, you're okay for a couple of weeks. If you have got it, great. If you haven't, go get it so you have it ready. And we're going to take a look at some of the content that's in here. So today, obviously, has anybody read this book? Probably not. Did anybody know that book was there? Did anybody look in the class even? Okay, just checking. Just checking. All right, so what I would like to do is so make a note to yourself, or this is Tuesday, Thursday, right? For Thursday, make sure you read chapter 1. Chapter 1 is where that assignment comes from. Chapter 1 is where your quiz comes from. So read chapter 1. I'm going to hit a few highlights off of some PowerPoints here, but I have a couple of other things to do here really quickly. So if you'll go back into Blackboard, I know everybody loves discussion boards, right? Wow, Spencer loved them so much he ran away. Discussion boards, unfortunately, are a necessary evil. It is a way we communicate. So the very first thing I want you guys to do so you can communicate with everybody is I'd like you to spend the next few minutes, and I want you to introduce yourself, including a picture if you can, and find one out of Facebook somewhere else. Or you could link to your Facebook or other social media if you really want to. So I want it so that I kind of have an idea of you guys, but we have online students, so everybody kind of gets together, and we can hopefully share, sing songs around a campfire. Scroll to the top. All right, all you have to do is click on the top, right there, and then you're going to create a thread. Okay. Create a thread. Yep. There you go. So we'll introduce ourselves. I'd put your name in there. All right, so I know you guys haven't read any of this yet, but I want to talk about a few things. And some of it you probably do already know. You just don't realize it. So a couple of things I want to do is we want to look at what's involved, what components, what operations, what are the steps in this process. We're going to talk about something called pseudocode. What does pseudo mean? Fake. So we're going to make fake code. Okay. Flowchart symbols. We're going to talk about variable names, data types. So we've got a lot of things we need to set up kind of in the background. Some of you, this is old hat. Some of you, this may be new things. So what do we have in a computer system? Well, we have the hardware. So that's all the physical parts. And then we have the software. So in other courses, we've dealt with the software and the hardware before. So if you've been in a programming or my 310 course, or if you've been in a web design course, you did some of that. So we're really going to separate hardware and software. So the software is what tells that hardware what to do. So in your car, Your foot is the software that tells the gas pedal how far to go down. And so we're going to look at those pieces. How do I control that car? How do I control that hardware? And what do we do? So programs then are sets of instructions, and they're created by programmers. So programmers create programs. Nice, okay? And so programming then is just writing out those. So it's not horrible yet. We're going to get there. We have a couple of different types of software. And generically, we have an operating system or system software. So that is Windows 10, your Mac OS X, Linux software. That is that operating system. So everything runs under that umbrella, and it runs something, a specific software, like an application software, this book calls it. So something that does a specific task. So a Word program, a game program. All of those are specific software, and that's what we're going to do. We're not going to rewrite Windows 10 here in this course. Probably just don't have enough time to do that. So a couple of other terms. Input. So some way we get input into a computer or our device. So they mentioned a couple. They mentioned keyboards and mice. Are there other ones? Are there other ways to get input into a computer? A scanner. What's becoming really, really popular right now? And I have one in my house called Alexa. There's a Google Home. Voice input is becoming more and more. So it's a form of input. Are there ones that can look at your eyes and see if you're blinking? So there's a lot of different ways we can get input. But anyway, we take information and we bring it into that computer system. We then take that data and we process it. So we have that data and we do some kind of organizational means to it. So maybe we check it for accuracy. So we get that voice input off Alexa and we try to see, hey, is that really what he said? So we checked it for accuracy. We perform some kind of mathematical operation. We set a timer, whatever it is we do. So I bought Alexa, and the best thing I found so far it does is keeps my shopping list and works as a great timer in the kitchen. Probably could have spent less than $50 to do that, right? But at least in those regards, that's what it takes is my voice input sometimes. So the processing is usually done by something called a CPU, or central processing unit. And that's when we think about a computer, how powerful it is. That's what really makes it powerful is that CPU, that processor. And so we actually are upgrading some of the computers in the lab. I have some money for it. So at some point, some of you guys in here, you'll get to see those actual physical components, that CPU. But they're getting more and more powerful all the time. Your phones are getting faster. Your devices are getting faster. Your cars are getting more powerful because they have CPUs in them. In fact, some vehicles have as many as 52 computers in them. Nice. And so then we process this data, then we have to have some kind of an output. So the output we're going to use in here is to a monitor, right? But are there other ones? We can send it to a printer. What else can we do with it? Can Alexa talk back to me? That's a form of output. There's all different kinds of outputs. And then what do we do with that output? Can we store it? Yeah. I can store it off on a flash drive. I can store on that hard drive. We can store it in a lot of different places. And so as we go through here, that gives us that idea. We take in input, we process it, and we create output. And it's all done by the CPU. Computer languages. So some kind of a programming language. Well, we have a lot of them to choose from. I haven't done a hard count, but I can find easily 600 different computer languages. Yes. Some of them are very similar to each other. Some of them are very different. They all do the same task, though, but they may be better tied to, maybe one is better for web development, maybe one is better for hardware development. So we pick a program that fits our needs. So the program we picked in here, does anybody know what it is yet? Python. And we picked Python for a couple of reasons. It's very popular. It also is very English language-like. So it looks very much like English statements that you're going to write. And so when we write them, we call it coding. And we code by using syntax. So that's that language rules. So the same as in English, we have rules about language. So like the language of there and there. Those are rules that we have for English. Now the problem though, we understand if somebody uses the wrong two, so they use 2, 2, and 2, right? There's 3 different versions of 2. And you use the wrong one, you can understand what they meant, right? Can the computer understand it? So syntax is very important. And those of you that have had something like a web programming course already, you already know that frustration of, but I meant it to say this. Why didn't the computer figure it out for me? Well, the computer is really the smartest thing we have, and it's also the dumbest. It only does what you tell it to do. And so there's a great statement called GIGO. Garbage in, garbage out. So it really means what you put in is what you end up with on the output. And that syntax is really, really important. And we'll find that out. We're going to go over it over and over again. So programming languages then. So we created in our very English-like language. And our code then gets translated down, all the way down to binary. Our computers, as I said, are really smart and they're really dumb. Your computer, your phone, your TV, whatever it is that's got a computer in it, can only understand one thing, a 0 or a 1. It is nothing more than millions of little light switches going on and off, zeros and ones. Everything we do is in binary. Great. But we don't want to have to mess with zeros and ones. So we have that difference between the zeros and ones and our programming language. Somehow there's got to be an interpreter in between there, or a compiler. And so you'll see that as we go along. So program runs. We have one more issue. So even we followed the syntax exactly. We thought, yeah, it all works. It all should code correctly. The syntax is right. But we have a logic error behind it. It ran exactly as we intended it to, except the logic is off. And so we have two things we need to deal with. We have to make sure it runs correctly and that it works in the way that we intended. And so we're gonna see some examples of those. And one of the problems though is those logic errors are harder to deal with because it runs. If a program doesn't run and says, hey, I stopped at line 47, you can find that error pretty easily. Logical errors get a little tougher, All right, so I am going to stop right here for now today. Go in, read the book before Thursday. I know that's a little bit of reading. We will look at the assignment, at least a part of it in class. So make sure you're here on Thursday. Make sure you've read the book. The quiz and assignments are both due by Sunday at 10 p.m. At 10 p.m., it's like a magic fairy goes in and they turn into zeros. So make sure you do those. Make sure you've introduced yourself. And if you haven't ordered the book, make sure you have ordered the book. I will let you know ahead of time, so if you want to save some space in your book bags, don't carry it with you until I tell you to. How about that? Yeah. So right now you have just an e-book you need to deal with. All right, any questions right off the hand? All right, don't expect to ever get out this early again. I'm just like, darn it. Unless you have all your work done early.